All right, so last week. Okay, so if you are ever absent from my class, let's just start here. If you're ever absent from my class, there is my YouTube channel that you can go on. If you don't remember where my YouTube channel is, it's on your dashboard or on your homepage for science in your dashboard. So this is what I'd like everybody to do right now first while we're talking about this. Do me a favor and minimize me right now and go into your Canvas. When you go into your Canvas, I want you to just go to your science homepage. And I'll give you a minute to get there, but go into your Canvas and go into your science homepage. Give me a thumbs up when you get to your science homepage. Okay, perfect. Okay, I've got 2 real thumbs that I've seen. Okay, thank you, Lexi. Good, good, good. Okay, you guys are there. When you go into your science homepage, you'll see that there's the picture of me with the blackboard. And beneath the blackboard, it says your Zoom link, right? So that's where you click on to come to this class. And next to it is your previous Zooms. Everybody click on your previous Zooms, please. When you click on your previous Zooms, you will see that there are a bunch of videos there. I've recorded the lessons, right? And it doesn't matter which one you go to because periods 1, 2, 3, 4, 5, 6, I only teach Science 7. So each period is the same. So if I say on there that it's about, phases of matter, you can watch that. It doesn't matter if I recorded your class or period 5 or period 2, it's still the same information. So if you did not come to a class for some reason, maybe you were traveling or you were sick or something happened, you had bad Wi-Fi, you can always go into that YouTube channel. You will always have access to that YouTube channel to watch anything that you missed. Besides that, if it is something that is difficult for you to understand, I heard people say, Miss Cook put 11th grade work on our Canvas. I would never put any work on there that is too difficult for you to do because I've given you all of the information that you need to be able to do it. So if you need to revisit some of my Zooms because maybe you checked out mentally, go ahead and revisit them. It's not going to hurt you any, but all the information is there and it's what you need. Okay. So while you're in my Canvas tile for science, click on modules and make sure that module 8 is there for you because I pushed it out last night and I just want to make sure that module 8 is available to you guys right now. If you have module 8, oh yeah, that's fine. That's fine. Yeah, I know, I understand. If you have module 8 pushed out, give me a thumbs up, please, or a yeehaw or something in the chat that says, yes, it's available to me. Emily has her hand up. What's up, Em? Maybe you meant a thumbs up. Okay, good. So I pushed out module 8. Thank you guys for answering with your thumbs up and in the chat and pictures and everything. I appreciate it. I put module 8 out today, but it's not due until December 4th, right? So if you look at that, you'll see the due date is December 4th because we're not going to really start module 8 until we come back from Thanksgiving. But for those of you that are going to be sitting there and you have nothing to do and you're like, oh, let me go check out science for some reason, it's there for you. Also remember that modules 5, 6, and 7 are opened, so you can go back and visit those again, okay? If you are, or if you're missing some work, you can submit it still, that's not a problem. The other thing is I've gotten some emails from people saying, hey, I did module 7.4 and it's not in Q as being graded. And that is absolutely correct. I have 200 students. It's going to take me a while to get through all of my grading, especially when it comes to that the vocabulary flashcards that I had you guys do. Each flashcard has 4 cells on it. There are 5 flashcards. So 5 times 4 is 20. So that means I have 20 cells to look at for each student, and I have 200 students. Do the math. That's 4,000 cells that I have to look at. Okay, so it's going to take me a while to get through those, but I will grade them and it will be pushed into Q. The way you can see the most accurate grade that you got on something, or whether or not something has yet been graded, is through your Canvas. So if you go back to that navigation bar and click on grades for science, everybody click on grades for science. Thumbs up if you're there, Chase. Okay, so you're in grades for science. If you look there, you will have a cumulative grade from the beginning of the year. But remember that we're only doing quarter grades. Some people wanted to see a cumulative grade. Some people wanted quarter grades. I went with cumulative grades on Canvas and quarter grades on Q. You will receive a quarter grade, not a cumulative grade. The reason why I sent you to grades to look at it is because you'll see on there, if something's been graded, you'll see a grade. But if something has not yet been graded, you'll see there are different symbols for different types of grading that needs to be done, whether it's for a link or something like that. So you can see if you've submitted it. And if you don't know if you've submitted it, you can go back to that page. If it's a discussion, it tells you on there, it's not a resubmit button, it's a subscribe button, right? So if you do a discussion, if you've completed the discussion already, the subscribe button will have a check next to it. If you completed something already and you've submitted it, that is not a discussion. If you look on the top right-hand corner of whatever sheet you're looking at, of whatever assignment it is, it'll say resubmit assignment. That means you've submitted it once already. Okay, so go in and click into Canvas and check out what you have there. And you can also look at your recent feedback. If you don't know where your recent feedback is, everybody click your dashboard. Go back into your dashboard and you'll see all your class tiles on the dashboard. Once you see all your class tiles on the dashboard, look all the way to the right on the dashboard and you'll have your to-do list. And then if you scroll down beneath the to-do list, there'll be another list there and it says recent feedback. In that recent feedback, you'll see what you've scored and anything that the teacher has written to you about the assignment. Okay, and if it says 27 more and it's in blue, click on it and you'll see 27 more recent feedbacks from your teachers. So that's a great place to look for information. I do a lot of feedback when it comes to if you need to make any type of corrections or whatever, I will give you feedback. And I give people feedback too when they do fantastic work. So look for feedback in there from any of your teachers, but especially me. Okay, so now you know you can look in Canvas to make sure that you absolutely handed something in, and you can look in Q for your quarter 2 grades. If the grade is not there for something you handed in, understand that I am grading as fast as I can. Okay, and I'm not going to grade like on Saturdays all day, and I'm not going to grade until midnight every night. I've been doing that for a while, but I'm taking a step back from that, building some parameters, if you will. All right. Okay. So that's all I wanted to go over with you on Canvas and on Q. take out your notes from the other day. We're going to review a couple of things. You should have on the top of those notes, you should have the definition for matter. Give me a yeehaw or a thumbs up that you guys wrote the definition for matter, because it's really important. Okay, Nathan says yes, Maria says yes, good job. Braden says no. Okay, so here, let me type it in the chat for you guys, for those of you who missed it. Matter is anything that has mass or takes up space. Okay, put that on the top of your list. Matter is anything that has mass or takes up space. So pretty much anything that's around you is matter, right? And then on that sheet, I asked you, where you took your notes, I asked you to write 2 lists. We have the physical properties list and the chemical properties list, right? Let's go over the physical properties list. We talked about, and we especially talked about this when we went over the periodic table, right? We talked about malleability. So check that you have malleability on your list, which means that it's the ability for something to be pounded or rolled or put into sheets, correct? Then we also had thermal conductivity, which means that it has the ability to transfer heat. And we talked about that when we talked about metals. Malleability, we talked about metals, right? It also, ductility is another type of physical property, which means that something can be pulled into wires. And we talked about that with copper, especially. Copper is used to make wires because it's a very good conductor of heat and electricity. We talked about density. Let me know if I'm correct, if we have density on that list. Density equals mass over volume. Thank you, Emmy. Density equals mass over volume. Good. And we said that the density of something never changes. Like if I were, I don't know if I talked to you guys about Minecraft, I think I did, but if I were to like get the mother lode of gold in Minecraft, and I forgot what it was called that you guys told me, but a piece of gold this big will have the same mass as have the same density as a piece of gold this big, right? Because it's just a math equation, mass over volume. It will always equal the same density. Gold has the density of gold and nothing else. Did we talk about color for physical property? Color of something, okay. I'm pretty sure we talked about hardness because we were talking about diamonds, right? And diamonds are the hardest. Yeah, I remember Braden chiming in with that one a lot. So that's good. Diamonds, hardness, right? Mohs hardness scale. Something can either be down by 0, which is the softest, or our diamond, which is a 10, which is the hardest. Did we talk about states of matter, phases of matter, like solid, liquid, gas, right? Good, thank you, Emmy. If I have solid water is ice, liquid water is water, gas water is water vapor, right? They're all water, but they're just in a different phase. And the last one was solubility. Did you put solubility on the list? Okay, good. So solubility is the ability for something to dissolve, and our like universal solvent would be water. And like Kool-Aid packets or Crystal Light packets or just plain old sugar or salt, you can put into water, stir it, and it will dissolve in the water. That means it has solubility. If something has the ability to dissolve, it has solubility. So that's all on your list of physical properties. Fantastic. Your chemical properties list only has 2, just 2. The first one that you should have on there is flammability. And flammability makes me very nervous. I don't like fire. But if something has the ability to burn, we say that it has flammability. Did we talk about that one? Bryn says yes, Emmy says yes, okay. If something has the ability to burn, then we say it has flammability. And the next one is reactivity. And reactivity is like a lot in one. It has, you're welcome, Emmy. It has, reactivity has a lot under it, meaning that it has the ability to change to a new substance. However that happens, and we'll talk about the different ways that reactivity, that you can see a reaction taking place. And I think we started talking about it when it came to the Statue of Liberty, correct? Did we talk about Lady Liberty? We did. You know what? I was talking to my friends about that the other day. We were talking about how copper oxidizes, and I learned something the other day. The reason why they used copper is, well, let me open it up to you guys. Do you know why they used copper for the Statue of Liberty? You have to give me a yes or a no. Some of you are looking it up on the computer right now. I looked it up. I was really interested why they used copper. Once copper oxidizes, and it took about 30 years for the statue to oxidize and turn that green color. It doesn't happen right away, right? So we were gifted the statue, I think in like 1860. Let me check to see if I'm right. And so they were looking at different materials to make it out of. And they chose copper because when copper is exposed to the elements and it oxidizes, and it stays in that oxidized state, that green blue color that you see, it will stay strong and not run the risk of deteriorating as fast as other elements or minerals or materials, I should say, would. So yeah, it was gifted to us in 1860. I think it was dedicated in 1886. And I actually saw pictures of Lady Liberty when she was copper, and she looks better green. And I think that's just because I'm used to seeing her that way. And then I looked on there because I was like, well, how long did it take for it to oxidize? And if it took that long, did we even have color photography then? And then I went into this whole big thing about looking at when color photography came about and everything. But they chose copper because when it's in the oxidized state, it will not oxidize any further. So it doesn't really break down any further than where it's at. So that's why they chose copper. So reactivity, I'm going to give you some examples of reactions, and those reactions you're going to put underneath your chemical properties. You're going to now title it chemical changes. And we're going to talk about different chemical changes that can take place. Okay. How can you notice, or how can you see when a chemical change has taken place? So obviously with the Statue of Liberty, we can see oxidation has taken place, right? Yeah, I think it's so cool to look at stuff, to figure things out. I really like doing that, Maria. Okay, so chemical changes. We talked about one. Oxidation is a type of chemical change. And I think at the same time we talked about rusting, because somebody put in there rusting instead of oxidation. Copper oxidizes, iron rusts. So they're different metals. They're going to react differently because they are different metals. Okay, and iron, like your bicycle or parts of your car or the nails that you hammer into a piece of wood outside, those will rust, but they will not oxidize unless they are copper, right? So you can tell if a chemical change has taken place if there is a color change. one, if there's a color change. A new substance is formed. So we can see that with rusting. We can see that with oxidation. But there's another one that I want to talk about. We are currently in the season of fall. With chemical change and the season of fall, if you were to go outside and look at the leaves on the ground, right, because they fell, because it's fall, the reason they fell is because those leaves are dying. Yeah, you all agree? Because those leaves are dying, they are not getting the nutrients that they need from the tree, which causes those leaves to change color. So that's why fall is one of my favorite seasons, or is my favorite season, because the leaves on the trees turn, especially on the East Coast, you know, bright yellows and golds and oranges and reds and things like that. And that's because a chemical change is taking place. Those leaves are no longer getting what they need to stay green and survive. So that's one. If there's a change of color, chemical change. Two, for chemical changes. Heat is given off or taken in. And you guys should be writing these down, right? Heat is given off or taken in. So that means that whatever it is that's in front of you is, one, either getting warmer, or two, getting colder. So the easiest one to talk about with that is, and if any of you have ever played any kind of sports, if there's an injury, they'll come to you with an ice pack and they'll crack it, right? And then all of a sudden that pack that was room temperature is now mixing with chemicals inside of it, and it's making it cold. That is giving off heat or becoming cooler, right? Because you can have hot packs, you can have cold packs. Oh, I didn't realize that I put that out just to, yeah, if you guys talk to me privately, then it goes to, there it is, sorry. So heat is either given off or taken in. And think about those ice packs and those hot packs. So now we have color change and heat being given off or taken in. And you guys are going to learn about something that's called an endothermic or exothermic reaction. And it'll make more sense when we talk about heat being given off or heat being taken in. The next one, for chemical change. You can tell if something is changing chemically if gas is given off and it's in the form of bubbles when gases are given off. So Alka-Seltzer. Many of you, when you were younger, made volcanoes and you added vinegar to baking soda. And you saw, oh, you need to try it, Makai. You get just a little bit of baking soda, pour some vinegar in there, and it will bubble over. There's a chemical reaction that's taking place, and it will bubble over. I see you have your hand up, Makai. What can I do?
So about the one by heat taking in earlier, but like for the soccer leg, it's like a glow stick. When you crack it, it starts glowing.
Okay, that's another one. That's light, and you just gave us another one. So fantastic.
Oh, okay.
You're ahead of the game right there. Yep. So now we have, I'll add that one next. Oh, Nick, you need to make volcanoes. You need to make volcanoes. Just do it in a small container and add a little vinegar to baking soda and it will bubble up. And then you can put food dye in there and make it red, and then you can have like lava flowing out on your volcano. It's pretty cool. So we have oxidation or rust, right? We talked about color change. Heat is given off or taken in. Gas is given off, so those bubbles. Maybe you want to try making a lava lamp at home. It's a very simple form of a lava lamp, but take an empty, small empty water bottle, soda bottle, whatever. And you're going to fill it 2/3 of the way with oil, like vegetable oil, not car oil, vegetable oil. Put a couple of drops of food color in there, whatever color you want. Like if you like blue, put some blue in there. And then put the rest of, not filling it completely, but put water in there. You know, oil and water don't mix, right? So what's going to happen is you're going to, after you put the oil and water together in the bottle, if you add an Alka-Seltzer tablet to it and put the lid on it, what's going to happen is that Alka-Seltzer tab is going to create bubbles because a chemical reaction is taking place within that bottle with the water and the Alka-Seltzer. And that oil is going to turn into little globules, and it'll look like a lava lamp because the bubbles will be, the globules of oil will be moving around through the water. So that's one way that you can make a lava lamp. Okay, so Makai gave another one. When light is given off. When light is given off, for example, a glow stick, when you crack the glow stick, what you're doing is you're opening these little vials that are inside the glow stick, and they're chemically mixing to create that light to glow. Another way is fireworks, right? Hopefully you've all seen fireworks. Yes, yes. And then lastly, I'm going to tell you it's when a solid, like let's say I mix two liquids together and a solid is formed. That solid, and it's not like hard like a table solid, but it's not liquid either. It's called a precipitate. So if a solid, oops, spelled it wrong, is formed, if a solid is formed, when we're mixing two things together, that is called a precipitate. Hopefully you're taking these notes down. So under chemical changes, let's just talk about it one more time, recap what we have there. Chemical changes. As far as reactivity, seeing when a chemical change is taking place, you can either see a color change. You can feel if heat is given off or being taken in. You can see if bubbles are being made, right? Gas is being formed. Those are the bubbles. If light has been given off, like our fireworks or our glow stick, and if a solid is formed, a precipitate. That's called a precipitate. Does everybody have all those things for chemical changes? For a definition for chemical changes, just so you guys know this, and I think you should write this down too, if you don't have it already. Chemical changes are when a new substance is formed that has different properties than the original substance, right? So a chemical change happens when a new substance is formed that has different properties from that original substance. Makai, yeah, I see your hand.
The last meeting that we did, we talked a little bit about chemical changes.
Okay, good. Good. It's always good to.
That's why I was confused. Change when you said change chemical properties into chemical changes, because I already had to write it down before.
Chemical properties are chemical properties. Chemical changes are something different. Okay, so they should be two different lists. In
Yeah.
order, so the chemical properties create the chemical change, right? Flammability will create the chemical change. Reactivity will create the chemical change.
Yeah. I have to steal fireworks from 4th of July and winning them to blow up in the desert. I'm gonna go boom.
Fireworks are cool.
Fireworks.
Fireworks are cool. Okay, so you guys have now chemical properties, chemical changes. Really, that's interesting. I would not set them off myself, Alexis. So we have physical properties. We talked about physical properties. You had a huge list of physical properties, right? Let's talk about physical changes. Physical changes, that is when no new substances are formed. So you're going to say to me, I'm going to throw this one out to you guys because I want you to really understand what I mean for physical changes, right? For chemical changes, you had a whole bunch of, you had a whole list to understand what a chemical change is. When you see different things happening, bubbles or light or change of color, those all indicate something chemical is happening. For physical, you're going to have something and it's always going to remain that substance. So the other day, I think I did this with you guys. What is this? It's a plain old piece of paper, yeah? What is it now? It's two pieces of paper. What is it now? It's four pieces of paper, right? It's just paper. It's not changing chemically. This is a physical change. We're just changing how many I have. I could tear this up as many times as I want, and it's still paper. I am not creating anything new. No new substance is being formed. It's still paper, right? And if I keep making it smaller and smaller and smaller, I have confetti, but confetti is still paper. I've not changed this at all chemically. But if I were to add heat to this, a flame, fire, right? If I add heat to my paper, it's going to change. Do y'all agree? Head shake, thumbs up. Okay, good. It's okay, Tegan. It's going to change. It's going to change into ash. I think we talked about this the other day. It'll change into ash, but it's not going to create as much ash as it was paper. And that's because it can also change, or it will also change into gas, right? So you'll have different gas elements entering the atmosphere, carbons given off, things like that. The most important thing that I think you should write, and you should write in all capital letters if you did not yet do this the other day, is that matter cannot be destroyed or lost. It can never be destroyed or lost. The matter that makes up this paper, the elements that make up this paper, they may not be the same elements as far as the way that they are chemically combined to make paper, but when they turn into ash and other gases that go into the atmosphere, it's the same elements, they just change. Matter can change, but it can never be lost or destroyed, never. Yes, Braden. And it's cheese is CHEESE. Okay, so I'm gonna go over a couple of changes with you, and I want you to type in the chat, type it to me privately, if you think it's a physical change, and you can just hit PC for physical change, or if you think it's a chemical change, and you can hit CC for chemical change. Okay, we'll start off easy. Tearing a piece of paper, is it physical or chemical? Maria, tearing a piece of paper. We're just going to tear it in half. Yes. Okay, good job, guys. Let's try vinegar plus baking soda. Physical or chemical? Vinegar plus baking soda. Okay, good job. How about this one? And remember, it's just either PC or CC, and I'd like everybody to join in. Troy, I don't see you on there. Nash, I'm just looking for somebody. Good job, Nash. Everybody respond to me, okay? And keep it private. Put it privately to me, not out to everyone, because I want to see what you guys know. Okay, so how about writing on paper? Writing on paper. Good job. Keep them coming, guys. Yes, yes. Absolutely. Good job, Diego. Yep. Okay. How about this one? Boiling water. Physical or chemical? Oh, good job, Daniel. Good job, Naima. Okay. Go back to your list of physical properties and chemical properties, everyone. If I take my liquid water and I boil it to make it water vapor, is it still water? It is, right? It's just going through a phase change. Anytime I go through a phase change, that's physical. You're not changing it, it's water. Do you understand that? Let me see if you guys, let's try another one. Glass breaking. What is glass breaking? Good. Okay, good. Good, good, good. Okay. How about sawing wood? Me being a lumberjack, cutting down a tree. Good. Okay. How about water evaporating? Oh, you guys are all over the board on this one. Okay, when something evaporates, it's going from a liquid to a gas, right? If it's going from a liquid to a gas, that means it's going through a phase change. If it's a phase change, it's physical. Liquid to a gas, it's still the same. It's just, again, it's going from liquid water to water vapor. Think of it that way. Liquid water to water vapor. It's still water, but it's a physical change because you're not changing it chemically. How about baking a cake? Baking a cake. In order to bake a cake, okay. So these are getting harder for you guys. Okay. So if we were to bake a cake, I have flour, eggs, vanilla, sugar, butter, whatever it is, I mix it all together. And then I put it in the oven. When I put it in the oven, what am I adding? What is the oven doing? Yes, Peyton, perfect. I am adding heat. When you add heat, look at your chemical change chart. Adding heat or taking away heat, that is a chemical change. The other way to think about it is this. If I were to take everything to bake a cake, could I separate those things out when the cake is baked? No, you can't separate those things out. It is a chemical change. You're ending up with a completely new substance, right? So the thing to think about is, try not to answer it so quickly. Say, am I getting a new substance? Let's try one more. Dissolving salt in water. Dissolving, dissolving, dissolving. Salt in water. Dissolving. Thank you, Alexis. Yes, yes. Dissolving, yes. Look at your lists. You should have written this down. Yes, Nash, thank you for changing. When something has solubility, that is a physical change, right? Solubility is a physical property. So if I take salt and I put it into my water, the salt is going to dissolve. Let's say I take that salt water, the ocean, right? How many of you have, let me know if you've gone to the beach and gone in the ocean. Let me know. Okay, okay. When you go in the ocean and then you dry off, have you felt sticky afterwards? That stickiness is because of the salt that's being left behind on your body. The water goes away. Water can evaporate and leave salt there. You can separate the two out. Salt has the ability to dissolve in water. It has solubility, right? That solubility is a physical property. How about making an ice cube? Physical or chemical? You're going from a liquid to a solid. It is a physical change. Good. Liquid to solid, physical change. Remember, when we go through our phase changes, it's physical. How about rusting iron? Rusting iron. Is iron a completely new substance? Or is the rust a completely new substance when it rusts? Yes. Rust is very different than iron. That is a chemical change. Okay, so time is just about up. I'm going to tell you guys, I want you to take a look at these notes, because when you guys come back after Thanksgiving break, we are going to play Kahoot. And it's going to be all on physical and chemical changes, okay? So I want you guys to take a look at these notes. I know, yeah, I didn't play Kahoot today because I didn't have enough information out to you guys to play Kahoot. But now you have the information, and it's a great way to come back and review. We don't have Thursday. We are off Wednesday, Thursday, Friday. So you guys enjoy your Thanksgiving. Abraham, tell your mom I said happy birthday. And if you guys need me, I'm going to be out of service for a while. It's my break also, right? So yeah, module 8 is out there if you want. Oh, Alexis, what day? Mine was the 19th. Get out of here. Happy birthday. You're my birthday twin. That's awesome. That's awesome. All right. Well, you guys have a great day, and enjoy your Thanksgiving. Enjoy your families. Stay safe. Okay. And I will see you on Monday the 30th. Bye. Oh, I'm sorry, Alexis.
Bye.
Guten Tagen.
Boom with fireworks and fire.
Woo!
Fire.
Bye.